So I'll quickly introduce Mr. Clay. So Clay, as you can see, is quite young. He's actually a former student of mine. He actually studied in the same lab I taught him many years ago. He is currently working as a senior software developer or a robotics lead at a company called Flow Mobility. Now, Flow Mobility is a company which 2020, they set up in 2020. So they are a purely robotics company. They make and they specialize in autonomous mobile robotic systems for various applications. They have one of their first products was a lawn care robot autonomous mobile system, and then they moved on to heavy machine and heavy construction material handling robotic systems, where they have a huge bot which carries a material, your construction materials, your bricks, your cement, your iron rods. It carries it from one place to the other autonomously. They also now work with agricultural systems, where you have sprayer robotic systems and other autonomous mobile robots that they make. Now, some of them they sell, some of them they use as a robot as a service. You might have heard of internet as a software as a service, SaaS, infrastructure as a service. So there's something like that. They use robot as a service. So they rent out the robot. Some company can hire out the robotic system. They'll take care of the maintenance of the bot, any system issues. They take care of it. So they work primarily with autonomous mobile systems, and they've been working with ROS2 for the past 1 year. So a lot of the industry has shifted to ROS2. So that is why when we were discussing this course, we thought we'd teach you ROS2, because by the time ROS1, so if you are familiar with ROS, if you're not familiar with ROS, it's okay, we'll teach you from the basics. If you're familiar with ROS1 is supposed to reach its end of life by next year. So we didn't want to teach you something that's going to die. So that's why we're going to be teaching ROS2, and you'll be using ROS2 for the next 2 days. Okay, so over to Flo. So he'll take over from now, and
usually I'm on that side of the room, not on this side. I used to sit right over there. Yeah, you know where you're sitting. Don't be offended if I keep targeting you for questions. Yeah, so main aim, what I want to bring about this next 2 days is I want to get you all familiar with Ubuntu 22. It's the latest release of Ubuntu. Ubuntu 20 is going to expire soon, so it's best to keep up to date with the latest software. And also ROS2. So every time Ubuntu makes a release, ROS also makes a release along with that. So it's best to learn ROS2 along with Ubuntu 20. So yeah, let's get started. How many of you all want to see yourself doing robotics in the next couple of years? Pretty there? Okay. Okay. So what made you all interested in robotics? Was it Terminator? What was it?
Iron Man.
Iron Man. Oh, okay. Good. Which one? 2, 1, 2, 3. 3 was not so good.
Actually, the first movie was Avengers, so from that, I saw Iron Man.
Okay. Anybody else? I saw so many hands. Some reason went there by all.
Just interested in logic, like how it's built and on the design part.
Okay. What about you? I thought I'll ask you.
Yeah, I really wanted to know how factories work.
Factories, okay.
Yeah.
Like as an assembly lines also?
Yeah, product as a service.
Okay. Interestingly, Tesla's factory is completely non-human. There's no human.
Yeah, that's what I
The way they make number of cars blew my mind when I heard about it. Anybody else wants to give one?
As a good development in the future. Robotics has good development in the future.
Yeah. That's a very valid point he said. So next 10 years you're going to see a boom in robotics and AI. I recommend.
It's good.
Right. So before we get started with Ubuntu, have you all heard the term Ubuntu? Can anybody tell me like what is it? Ubuntu? What do you at least know about it?
Operating or an operating
It's an operating system. Yeah. Any other difference? Yeah.
Most of the robotic softwares are run on Ubuntu.
Yeah, that is true. But what is it? What he said is correct, but what is it? Any other difference? Okay, I'll do my best to explain. So generally when people hear Linux, this is what they think for this. Which one of these two? Linux actually, if you first, you must have heard the term Linux. Everybody is using Linux. People think hacker. What is it? Ubuntu is actually based off of Linux. But what is Linux? So have you all heard of the term Unix? Unix. So Unix was actually created by a guy called Dennis Ritchie. You must have heard the name Dennis Ritchie. Dennis Ritchie. Can't hear you again. The lab is soundproof, so you can't say. The guy who invented C. So that's Dennis Ritchie. Somebody said CC. I just heard us. So he and another guy, they made Unix together, and that was property of AT&T Bell Labs. So that was actually a paid software. So people didn't want to pay for the software, so this guy, Linus Torvalds, he made Linux. So he sent out an email one day saying, hey, I'm making a new version of Unix, completely free. You can just download it, don't have to pay me anything. That is when Linux started. Now, Linux is the one operating system which is run on more than 6 billion devices on the planet. 6 billion. That one operating system. And it's one of the most secure. To this day, nobody can crack SSH, the SHA-256, the algorithm used for making SSH keys. Linux was one big contender in that. And many people have also contributed to it. So he started the term open source. Open source is essentially making software accessible to everybody, open, not closed source. So from, if you see this ridiculously complex graph, this is just a simple timeline, don't have to be scared about it. This talks about how when Unix started and how it transitioned to where we are today. So if the phone which you're using runs a version of Unix, be it Linux or be it Unix. If you have an iPhone, it runs Unix. If you have an Android phone, it runs Linux. And all the servers you see in the world, 99% of them run on Linux. Either Ubuntu or I'll come to the next set of things. So this is a brief description, and you might be wondering, have you all seen this penguin somewhere before? Whenever you mention Linux, this penguin shows. Have you all wondered like why is the penguin over there? Was it his pet? Was it so? Turns out this guy was actually bitten by a penguin in the zoo. He was bitten by a penguin and he thought he caught a disease called penguinitis. So with that he adopted this as a new mascot for Linux. So that's about the penguin. And you must have you all seen these logos somewhere? Or just Ubuntu? You must have seen these somewhere, yeah? So these are essentially distros of Linux. If you see this thing over here, during this time 2000 to 2010, many developers started contributing to it. Everybody liked the concept of free. Nobody doesn't like free, right? So you have something free, and people contributed heavily. So if you see on just open GitHub once, let's see the Linux repository. So it's maintained by the same guy, Torvalds. He's still alive, by the way. He's still alive. He is maintaining it. He sits somewhere in Finland. You should see his setup. Very weird. He has one table, long table, one computer, one old monitor, and one very old keyboard. That's all. Nothing else. Nothing fancy. He doesn't use Windows, Mac, nothing. He doesn't like any of them. So he maintains this, and you see, these are the number of stars on GitHub. This is like one of the largest star repositories. Star in GitHub essentially means somebody who likes it, who follows it, keeps up with it. So this is the source code for Linux, and if you see These are the number of commits, 1.25 million so far. That was when he added it to GitHub, but it was there long before that, so there are even more commits. I'll come to what exactly is GitHub commits and all these things. I just wanted to show you what where Linux is being maintained. This is the definition of open source. So I just entered a URL. I go over here. I can see the software. Entire source code. Whatever is going to run on your phone, it's over here. Artist or a part of it. So yeah, that's about this guy. He also invented one more thing which we're going to see today. I'll get to that. So back to distro. So why is this distro important? So once Linux was released, distros started kicking in. People started making their own forks of Linux. One fork was FreeBSD. BSD is your Berkeley scientific division. They made a license for that. Berkeley software development. Sorry, Berkeley software development license. That is one version of Linux. That is what is being used on every computer today. Most of it, BSD, FreeBSD, and there's something called GNU. GNU is your OS which is running. So the acronym for GNU is actually very interesting. It's actually a recursive acronym. So GNU stands for GNU is not Unix. So GNU, G is for GNU is not Unix. So it's a recursive acronym. I heard that. So I don't know why people put that acronym. It's very weird. I don't even understand that to this day. But the reason why I'm saying why these distros are important is each distro has its own application. Like in enterprises, nobody uses Ubuntu. Ubuntu is completely free or open source. It is crowdfunded. It's a non-profit organization. But people still pour millions of dollars into it. And this Red Hat is another form of Linux. It's forked from the Linux kernel, and they've made a new version of it. So Red Hat is actually a company. They provide enterprise solution software for enterprise software solutions for big companies. All server farms and all, they run on Red Hat Linux. And CentOS is actually a free version of Red Hat. So people who made CentOS were like, no, we don't want this to happen again, so we're going to make CentOS. So they made this. And this was just like a collection of programs. Like any set of programs, certain specific set of programs, and like a file system. I'll come to what a file system is. That is what makes a distro. You can all of this how to install it. You can just do a simple Google search. You'll find it. It's one of the most searched things in the world. And this is like an example of it. If you see, I'll come to what Debian, RHEL, SUSE are. This is not very important, but these are like pretty important. Debian is one family of Linux distros, like forked from the Linux kernel. You have like the main kernel maintained by this guy sitting in Finland, and you have these being maintained separately. So whenever this guy makes a change, these guys get to know about it, and they merge these changes into their own repositories. So whatever you saw on GitHub, that's called a repository. Have you all used GitHub before? You've used GitHub. Very little. Not to worry. End of this day, you'll know exactly how it works. Yeah. So they pull those changes and they merge it into their own repositories, and that is how the thing goes. And if you see this thing again, this guy is not the one committing it. He's not making any changes himself. He might make 1% changes of the entire code base. Rest 99% are actually contributed by the public. Some guy sitting around the world, they will just find some bug, make a fix, and then they'll create a pull request. I'll also explain what a pull request is later. If you see, he keeps deleting them, so you don't see a lot. But yeah, so this is by some guy, Sparsh Resta. I don't know who he is, but he is sitting somewhere, probably in India, making some changes, and he made a request to this guy. Hey, merge my changes. It's something interesting. That is how this entire community works. Now, why is this important? ROS is also like that. So, the moment you enter the robotics community, everything is open. Most of it is open source. People want to contribute. People want to share knowledge, and this philosophy which he created actually inspired every open source solution across the planet. The concept of sharing this information, putting it so that people can actually contribute back. This way, the entire community grows. That's why you see robotics is a very advanced field today. One of the most advanced fields you can think about, AI robotics. Both communities were driven by open source initiatives. Okay. And that's just about distro. And coming to, I'm just touching on this so that you get to know how exactly your system works. I won't go into detail in this, but have you all wondered, like, when you press the power button, what exactly happens? How does the screen light up? For me, like, when I press power button, I want my game to start. So that's what I used to do most of the time. Give me any answer. Like, there is a right answer actually, but I like to hear from you. Nobody? Come on, guys. Okay, I'll explain. So when you press the power button, something called a BIOS boots up. So on your computer, you have a monitor, you have a keyboard, you have a mouse, and then you have few other units like a motherboard. On the motherboard, you have your memory, your permanent memory, you have your volatile memory, your RAM, and you also have your power circuitry. That's essentially what your computer is, be it your desktop or be it your laptop. Laptop is just a small version of your desktop. So why is this important? When we're doing a couple of operations in ROS study, you'll know exactly why these things are important. So first thing which boots up is your BIOS. BIOS stands for
Basic input output.
Yeah, good. Basic input output system. So what that does is that essentially fires up your basic input, your keyboard, your mouse, it does a memory test, it boots up your monitor just so that you can inspect it, do any troubleshooting if necessary, and so that the other applications, the rest of the chain, can access those peripherals. So that's essentially what BIOS is. It's nothing complex. There is another way of putting it. I'll show you that as well. So once the BIOS boots up, you get your master boot record. Master boot record is a small partition in your hard disk or your SSD. It's a small location, roughly around 512 bytes. So that tells the bootloader, that's the next part, that is where the rest of the system is. That is what the master boot record does. Once that happens, the bootloader then fires up the Linux kernel. This is the heart and soul of your PC. Your Linux kernel fires up, which in turn decompresses itself to give your Linux file system. And then you get your cool terminal. That's essentially how the full process works. So you must have seen a screen like this sometime. So that's your grub. Grub is actually a bootloader. It's one of the open source bootloaders. Another bootloader is called ISO Linux. We don't have to cover that today. Grub is like the most commonly used bootloader you can think of. So this Android, actually, you have the embedded devices, right? On like your phones or your Raspberry Pi. You all know about Raspberry Pi? Raspberry Pi is also a computer which runs mainly Linux. You can run Windows also, but nobody prefers doing that. No sane person would prefer doing that. So this is the conventional way of booting, like what you have on your computers, and this is something called UEFI boot. So UEFI boot is the way the boot happens is slightly different. Here you don't have a master boot record. Here you have something called an EFI bootloader. We will not dive into this today. This is generally for embedded devices. When you're firing up your Android phone, the moment your phone is powered off and you press the power button, this sequence happens. So the bootloader resides in a small register on your phone, and once you press the power button, that register is activated, and then the boot sequence gets triggered, and you end up with your screen. So that's all about this. These are some important things which we will be getting into right now. I know you all are eager to access the terminal. We're coming to that. I just don't want you all to mistakenly do something which will crash the system. So just to get a brief understanding. So entire Linux is based on something called a file system. So you must have heard Debian file system, RHEL file system, all these fancy terms. So what exactly is this file system? File system, as its name suggests, it's a set of files with certain directives, permissions, and all of that grouped together is your file system. So the reason why this is very important is in Linux everything is a file. Literally everything is a file. I will come to that. robotics, right? These are some examples of file systems. Linux uses ext4. NTFS is proprietary by Windows, and exFAT and ext4 are also used in Mac. So this HFS is one new format which they recently started using. So we'll not cover that today. But your ext file system looks something like this. If somebody is really interested in diving into the exact arrangement of your registers, you can visit this site. But that will not be the scope of today's discussion. So everything is in a file in Linux. Even directories, even folders, everything is a file. So why is that very important? It's important because everything, like how your process communicates to another process, how files are shared between each other, how one computer talks to another computer, everything happens through this concept of file. So this is an example of my laptop. I just typed this command ls-l. This lists out all the items in a directory. So if you see, all of these are files, even directories are considered files. And to do these operations, I'll get to that. So a couple of file types are, you have your regular files, which are normal text files, scripts, normal programs, and then you have your directories. Directories are which host regular files and other types of files. Then you have socket. I'll come to what socket is. Socket, in brief, is essentially a channel of communication between one process to another, or within a process, two sub-processes can communicate. That's what a socket is. Links are essentially, if you have a file in one directory and if you create a link essentially is some sort of a channel, not a communication channel, but sort of hyperlink. You know what a hyperlink is, right? When you click on something, it takes you somewhere. Sort of like that. That's what a link is. And pipe is again like socket, but the way pipe is and socket is slightly different. Blocks are again your memory unit. So when the Linux kernel boots up, it looks for your hard disk. That hard disk is actually block memory, or your SSD, that's also block memory. So that gets identified as a block device. And then characters are, these files essentially are your devices. So in Linux you have something called your dev folder. I'll just show you that. I promise this is only the boring part. We'll get to something more interesting soon. Yeah, so I'll just show you. Can everybody see this? Is the brightness fine? So yeah, this dev folder in Linux essentially is your folder which shows all your devices. Devices are essentially your peripherals, whatever are connected to the main CPU. So if I list out everything, all these are the different things connected to my computer. Right now nothing's connected except this, but internally a lot of things are there. So if you see, all these are classified as, the first character in this represents what type of file it is. So if you see, this is a character file. There are a few other things. You have a directory over here. Then you have a link. L is a link. B is a block device. So this is my hard disk over here, my SSD, NVMe slot. So I can actually show you command. If you type df-ha, this will list out the entire all the blocks which are available. So my hard disk is over here, 512 GB SSD, and these are all part of the file system. This is an interesting thing. I'll come to that. Will not touch. Yeah. So that's about files. Now the terminal. This is the heart and soul of Linux. Any Linux developer needs to have this. You wake up in the night, you should be able to tell what exactly happens in a terminal. So terminal is essentially your interface to the operating system. Your operating system does a lot of things. So how can you interact with it? One way of interacting is by designing an application which runs on the operating system, or you can use the terminal. Terminal is something which the maker of the operating system gives you by default. Any Linux, any Unix operating system worth their salt will give you a terminal. So this terminal is a portal into the operating system. This is something called a command line interface. So in the terminal you type commands, and that sequence of typing commands is called a command line. And since this is an interface, and CLI, command line interface. So Now question is, once you type a command, how does the operating system know what to do with it? Somebody should tell it, right? That's your shell. So your shell is essentially your interpreter for these commands. You type, I type over here ls, right? Yeah. I type ls and df-x. How does the operating system know what that is? So the shell is the one responsible for interpreting that. So what this does is it communicates with the kernel, and the kernel it returns a response. So this is the data the kernel returns. So that's about your CLI. Now is where we interact with the system. So can you all log into your systems and open the terminal? To open the terminal, have you all logged in? Everybody logged in? Okay. Yeah, just press the start key and type terminal. Everybody has the terminal open? Okay. Yeah, so we'll go through a couple of commands which are like very useful in Linux. So if you have a directory, if you want to list out the items in it, just type ls. Type ls and see what you get. The most common command you will use in Linux, ls. So what you saw in the output, this way of all these this listing is a communication from your kernel. It tells you like, hey, these are the items within this directory. And to know what directory you are within, just type the command pwd. Pwd means present working directory. Everybody got it? Now, interesting thing is, in Linux you also have a concept called hidden files. Some files are not shown. The files which begin with the dot character are all hidden files. Those are not shown at all. So to show those files, generally those files are important because they are configuration files. Most of the programs look for these dot files, and they don't want to expose it so that it's an inconvenience. They mainly want whoever is working on that in that directory not to have the hassle of going through so many configuration files. So they add a dot in front of it. That's the general practice. So to list out all of those, just type ls-la. ls-la, what essentially that does is, L represents list in the form of a table, list kind of thing over here. The previous thing was an unordered list. This is an ordered list. And A represents all. So if you see even the files .vimrc, .viminfo, if you see on my screen, all these show up. Previously they did not. If I just type, even if I remove yeah, if you see those files don't show up. So A represents all. And interestingly, most of the commands in Linux, they have something called a help option. So if you have a command and you don't know what to do with it, just type --help. This will give you a quick help reference. You can go through this, see, check out anything you want.
What do we need to type?
Yeah, let me type the command again. Let me know if I'm going a little fast. I want to reach the interesting parts. These are like just some commands to get you used to the terminal and used to running it. Yeah. So ls-help. Double-help is generally the convention. You can even, I don't know if H is there. No, H is not there. Double-help is what works. Everybody got it? Any questions till now? I'm sorry? What? Yeah, you have to give space. Otherwise it will come like this. So all of you all are running bash. Bash is essentially called born again shell. That is the name our guy from Finland gave. Born again shell. I don't know why he chose that, but that's one type of shell. I use on my PC ZSH. There's not much difference between bash and ZSH. It's just that ZSH is a new shell. Apple started adding ZSH into their shells as their default shell into their MacBooks. So if you get a MacBook and you open the terminal, you will have a ZSH interpreter, not a bash. Yeah. So all of you have got ls command. Yeah. So most common command you use is ls-la. So some computers have an alias. So alias essentially in Ubuntu is another name for a command, just as the name suggests. So in my PC I have ll. If I type ll, it does the same thing as ls-l. Can everybody try that? ll? Also, the PPT I just brought it here so that for namesake, most of this is available online. Simple Google search will give you. It's one of the most supported things on the planet. So I mainly want to walk you through a practical session. So we'll be mostly interacting with the terminal together. So any queries, please ask me right away. We'll definitely resolve it. So everybody tried LM? LM. Right. So another couple of commands are. You have CP. CP essentially means copy. So copy, as the name suggests, it copies files or directories into another location. So if you, let's say, let's create a file. So to create a file in Linux, you can use the command touch. Let's call it test. So for me to find out if test is there, I will come to what this command grep does, but if you can see, this is the file I just created right now. February 3rd, 1207. 1207, right? That time correct?
Yes.
1207, yeah. It's right there, fine. Now if let's say I want to copy this file, I just do cp test, let's say I want to put it in my temp directory. There's a directory in Linux called temp. I'll just copy it there, and now let's go to temp. Now, to switch directories, from where I am right now is home/flow. Now if I want to go into temp, I just do cd temp. CD means change directory. So now if I look for test, yeah. So if you see, the file we copied is right over here. Now you all might be wondering, what is the grep? So grep essentially means global reject sprint. So this grep, what it does is you pass in a stream of data to it. It will sort it out based on regular expression. It will use that regular expression and print out the output related to that. So every output in your shell is a stream. So in Linux you have three streams: std in, std out, and stdl. So std in, as the name suggests, it's your input. You all did Java, right? So when you did Java, you must have done scanner, sc, new scanner, sc.next. So that stream is called your system.in stream, your input stream. So stdin essentially helps Java to get you the input from the keyboard. That is what stdin is. And now stdout is your output. So whenever you do system.out.println, it goes somewhere, right? It goes to the console. That going to the console is your stdout. Now stdl is your error stream. People generally, like for example, if I type let's type a command which is not there. So whatever got printed out here is your stdl. Now you might be wondering, like, why is the terminal showing stdout and error? So turns out all terminals are configured to pop out your stdl and stdout, and they take an input via stdin. So those are streams in a nutshell. Now the streams have numbers. So in Linux, if you go to the dev folder, can you all go to the dev folder? You all are in the dev folder?
Can you use the command for the?
Yeah, so command, the folder's name is dev, right, /dev. So how do you go into the folder called /dev? cd/dev, exactly. cd/dev, you'll go into that. Yeah, if you go in there, you'll actually find your stdr, stdin, stdout there. Can you all see? Can you all see it in your systems? Actually, you know what? Let's try this. You all try using the grep operator here. Type ls-la grep stdout. See what you get. So this is like the basic way of searching for things in a directory. When you are given a Linux system, you generally have only access to shell. Most servers, you don't have a UI. So you have to be proficient in the terminal. You need to be able to navigate around directories. You need to be able to see what's inside a directory. That's the essential goal of this. So the grep command is generally used in these cases. You like even if I type, let's say, if you want to print something in the shell, just type echo. If I type echo hello, it prints this to the shell. Now if I add a grep and hedge to that, it will highlight to me the hedge in hello. That's what your grep does. Grep is used in like many places. Like if let's say you're reading a file, you don't know, it's a really huge file. Like I'll show you an example. Let's go into one of the configurations. Yeah, this is a huge Python file. Now, for me to read this, it might take too long. Let's say I know that there is some character within this file, and I want to figure out where that is. So if you want to print the output, the contents of the file, if you want to output that, use the command called cat. Cat means concatenate. So it concatenates the output of that file into the std out over here. So what is the name of the file which I just opened? One Python file, right? Let's actually search for that. .py. Oh, there it is. Now I'll type accessories. So you can actually search. Since the regular expression .py, I actually found out the file is over here. It highlighted that .py if you see. So if you type cat, now the entire contents of the thing are outputted to this. Generally, this is just a 200-line code. Some programs have 1,500 lines. Some programs have 2,000 lines. So in those cases, what do you do? Let's say you want to see something specific. Let's say I want to find out in Python what's the most common thing a person would look for. Functions, right? But you all have done Python the first semester. Right? What is CSC 1701? Is the code different? Something else. Okay. When I ran it was 1701. So let's say I want to search for functions. I type def over here, and if you see everything related to def showed up. Now you can put any regular expression over here. In the same course, you all must have done regular expressions also, right? So I'll not get into that, but you can put any regular expression over here, and it would output you. It would highlight the output of that regular expression. So in this case, it's just def def. So it showed up everything. It showed everything related to def. That's the grep cat ls and your cp command. Now this is an interesting command, move. So you might be wondering, okay, it just moves the file. What's so great about it? So the thing is, renaming a file in Linux is actually moving it. There's no renaming. There's no concept of renaming. It's only move. You move a file into a new file. So let's say I want to move this file. So how do you list out the files in the directory? Can anybody tell me? Yeah, ls. Okay, good. So if you see ls, give me this. Now let's say I want to rename this file. I do this. The name of the file, and let me give it a new name, test.py. Now if I do ls again, what do you think would be there? A test.py, yeah. So that's about renaming files. Now there's an interesting topic, permissions. So what exactly are, like, we talked about files in the beginning, right? I mentioned how important it is. So files actually, turns out they have something called permissions attached with them. So when we did ls-la, can everybody do this ls-la in your system? Like take any directory you want, do ls-la. You'll get an output.
Can you explain how to open a file?
Oh, okay. How to open a file or how to read the contents of the file? Because I haven't showed you how to open a file.
The command where you showed about cd.
CP copies the file. It doesn't open the file.
Oh.
Yeah. So if you want to open a file, so your terminal can't open a file per se. Like it can read the contents, it opens and immediately closes it. If you want to open the file and view its contents, you have to use something called a text editor. So we'll get to that soon. That is also part of today's plan. So a text editor would essentially give you access to edit a file, to go into it, see its contents, edit it, search, do any of those things. The most common editors in Linux are Nano and Vim. You must have heard about these terms, Vim, Nano. Okay, fine. That's fine. We'll go. So now coming back to permissions. So when you type ls-la, what do you see in your system? Like what do you see in your system when you type ls-la?
Maybe that.
I'm sorry?
Maybe fails to that.
Yeah, sure, right. But you might be wondering, like, what is the first characters? Like, what do they represent? So this actually represents the permission structure of your file. Like, if I create a file, how can other users or other programs access that file? Like, what can they do to that file? What are they restricted in doing to it? So that is what this describes over here. So the syntax of this essentially is the first part of the permission set consists of your permissions for the owner of the file. So in Linux you have something called concept of groups, users, and your groups, users, permissions, and context. Context I will not get into now. It's for something called SE Linux. SE Linux is security enhanced Linux. That we'll not get into today. But for somebody using Linux for the first time, getting into it, this is like a very good start. The first block represents the permissions for the owner. So in my PC over here, so I just type users in your PC. You'll find 2 users if I'm correct. Users is a command which lists out all the users. So most of the session will be like this. I'll be typing out commands. I'll explain what they are, and just please note them down and remember. These are very useful. More often you start using these commands, you'll get the hang of it. So don't be dismayed if you're not able to remember, not able to do it in the first go. So users lists out all the users in your system. So can you tell me like what users do you find? Or what's the output of that? Sudo users. I'll tell you what sudo represents. Generally, that lists out all the users on your computer. So if you see in the output of ls-la, you also see the column over here. This represents the owner of the file, and this represents the group. So I'll get into what groups and users are later. But in terms of this, the first block represents the read and write and execute permissions for your owner of the file, like the person who created the file. In this case, person can be the user who is operating the terminal. It can be a program. Program can create a file, right? A program can create a file, can delete a file. So that's what these permissions represent. And the next set of permissions represent for the owner of the group. So the groups are essentially an umbrella term for all permissions. So this is in such a way that if let's say you're added to that group, you can experience all the privileges of that group. So in my system over here, you see this section is your group. So I'm part of the flow group over here. Now if I switch user, so sudo essentially is you have one more user in your system. You can't access that today because access to the root user is not allowed. But as a root user, you can do a lot of things. The whole concept of root user is you have unrestricted access, no restrictions, no issue of privileges. You can do anything you want. You can delete the file system. You can do whatever. That's the whole concept of root. You must have heard root access somewhere in movies and all, right? Yes. The same thing only over here. So su means switch user, and sudo represents super user do. So if let's say I try to move a file which is restricted, let's go into a directory which does that. So my terminal, I have a plugin which shows me, this lock means it's actually owned by the root. So if you see over here, everything is owned by root. Now if I try to do any operation, it will not let me, even if I want to read a file. Let's take a file which I can't read as a normal user. interesting file we can find. See, all these files are reads, so we'll have to create one of our own. That's okay, we can do that. Touch, test, and now if I list out all the things related to test over here, you can see that test has RW, RWR. So RW essentially means read and write permissions. Now in Linux, your permissions are categorized with numbers. So read has a value of 4, write has a value of 2, and executable has a value of 1. Now, why is this important? Because when let's say you want to change the permissions of a file, the command for that is chmod. Chmod essentially changes the changes the permissions of that file. Can you all create a file on your PC? Just use the touch command and create a file. Anything, call it anything you want. But just remember the name. You all created a file, yeah? Yeah, go ahead.
Command shows us all the directories of the file.
No, it shows you everything. A represents everything. So it lists out all the files and directories.
So files are within directories.
No, so it won't show you the files within subdirectories, but it will show you the direct subdirectory names.
Oh.
Yeah. You all were able to create a file? Yeah. Use the touch command. Touch. The touch command just creates a file. It doesn't do anything to the file. A file is empty. If you see, it's 0 bytes. Yeah. This just represents the file itself. Otherwise, it has nothing. If I do cat test, I just create an empty file. It's 0 bytes. Nothing. If I cat test, there's nothing inside it. That's what touch does. Touch just creates a file. Nothing. It doesn't do anything to it. No content. Nothing. Can you all do ls and see if the file you created is there? See what you get.
It says permission.
Where are you all creating the file?
In there.
Oh no, don't create it in dev. Don't come out of dev. Dev is a restricted folder. That is an example of no. Actually, you are all in dev, right? Add sudo before that and try it. Add sudo. If you are in dev and you accidentally created it, add sudo before that and see. This is an example of sudo. You got it, yeah, no? So sudo means super user do. You are essentially telling super user, hey, do this on behalf of me. Any questions so far? Any questions related to the command we saw?
What is cat?
Yeah, I'll answer this question first. So cat essentially, it takes the contents of a file and it outputs that. That's what cat does. Yeah, so if you have a file, like if you type cat and then the file name, it takes the contents of that file, it reads it and then puts it to the terminal. And that's what cat does. Did I answer your question? Yeah, your question. You want to switch directory? So currently what directory are you in? And to do that, to find out what directory you are in, use pwd. That will give you where you are right now. Since you are in dev, if you want to, let's say, shift, type cd and the name of the directory, the path of the directory you want to go to. So,
What if we type only C?
yeah.
What if we type only C?
If you type cd, that's a good question. So if you just type cd, you will be taken to your home directory. That's your default directory. So if I type cd and I type pwd, this is my home directory. Let's go somewhere else. Now I'll type cd. I'm back to home directory. So this is just a shorthand so that you don't have to type the full path all the time. And there's actually one more shorthand. If let's say you're in dev, now if you want to go home, you can also do cd tilde. This squiggly line you see, right? That's called a tilde. So if you do that, you'll be taken back home. Now tilde is also a prefix for any path in the home directory. So let's say in my home directory I have this folder videos. Right. Let's say I'm in dev. Now let's say I know I have a folder called videos and I want to go there directly. So all I have to do is cd tilde/videos. Now I'm inside videos. So can you all try that? Go to some random directory and try going into the home directory. Let's say the documents folder.
Type cp/dev, it shows no such file or directory.
So how are you going into that? Like CD space slash dev. CD.
Just CD slash
No, not CP. It's CD. CP is change directory. Don't copy. CP means copy. CP is copy. CD is change directory.
You have to put a space.
Yeah, any command always have a space after that. So whatever follows the command are called arguments. Yeah, go ahead. I'm sorry. Can you speak a little louder? Sorry, I really can't hear you. Can you tell me a little louder?
When I use touch to create a file, what kind of file is
An empty file. Now, like based on the extension, since I did CD test, it's an extensionless file. So file just means there's content within it.
whereas
Yeah.
like file.txt.
Yeah, so if you do touch some file name .txt, a text file will be created. Yeah, so different programs who, let's say, use text files, they can interpret that, hey, there's an extension called .txt, let me make use of it. So even in Windows, when you create an empty file, you don't get that notepad icon, right, on the file. You don't get that note, but when you change the name of the file to, let's say, a.txt, immediately the notepad icon comes up. Yeah. So that essentially is what happens in this as well. Some programs recognize that extension and they make use of it. Have you all tried this? You're able to switch directories? Any queries so far? Yeah, go ahead. How do you move a file? Remove a file. You asked, you are venturing into the right territory. So let's say you create a file and now you don't want anything to do, you don't want to do anything with it. Let's say I want to get rid of this test. So to do that, use a command called rm. Rm is a command which you need to keep in handy. Rm essentially it removes that file. Rm means remove. Test. Create a file using touch and try removing it. You all able to do that? Any difficult? Essential because when you're working with ROS and trying to create programs, creating files, deleting them will be part of the process. Yeah, so you all were able to create a file and delete it. Now question is, how can you create a directory? So to create a directory, use something called mkdir, make directory. So mkdir, let's call test dir. Now make a directory and try searching for it using grep. You are able to remove the directory. Try removing the directory. You will find something interesting. Try doing rm and the directory name.
Cannot remove.
Yeah, what does it say? Cannot remove?
Cannot remove directory.
Yeah, so just by using rm you can't remove it. So you need to add something extra. So whatever you add over here, these are called flags for a command. So if I go to the help section of rm, everybody try this thing, help section, rm double-hyphen help. Yeah, you will find in the R section of the help, you will find that there is a flag which enables the command to remove directories. So that is called the recursive flag. So generally, most of the commands in Linux follow the same convention. If you want to do something repeatedly, like remove directories and all, people use this recursive terminology. So even rm does that. So if you type rm-r, type the directory name. Type the directory name and try searching for it again. Yeah, shoot.
What's the command to create a directory?
Yeah, to create a directory, type mkdir. dir, yeah. mkdir. mkdir stands for make directory. Yeah, so what did the search result in? Good, nothing, right? Empty, right? So your directory is successfully deleted. Yeah, somebody asked a question. Okay, fine. Sorry. Did anybody ask me a question?
what is recursive? Like remove directories and leave contents network. What is recursive?
Recursive. So have you heard of recursive functions? Function within a function. Same thing only here. So recursive here stands for contents within content. So directory is example of that. It's a content of content. So it's a special type of file, right? So to remove that special type of file, you need to recursively remove it. Yeah, that is essentially what it means. So when this test dir, right? Let's say there is some content within test dir, some more files. If let's say there are. So to remove all those and to remove this file, you need to do it recursively. That is the whole meaning of recursive. It applies for every concept in Linux. And let's say you have a folder which doesn't go. Let's say you type rmr and it's still there. You can always use the force flag rm-rf. Try creating the directory again and then use rm-rf and delete it. You will get the same result, but yeah, you will get the hang. You all got it? Hang of how to create files, how to delete them, move them, copy them, rename them. Okay, awesome. Yeah, I'll show you some more interesting commands. Let's see if we covered everything. Yeah, coming back to the chmod. So there's a nice command in Linux called chmod. Chmod essentially changes the permissions of the file. So if let's create a file, test, and let's output the file over here. So if you see, permissions over here are read, write, and read. So in Linux you can actually express this as a number. So each permission placeholder, right, is actually sum of these values over here. So if it is rwx, what would the permission value be over here? rwx 7, yeah. So essentially the permissions for this, the one on the screen, is 777. So if let's say I want to change this test, or before we change, what is the value of test, the permission value over here? It's rw.
664.
Yeah, 664. So now if let's say I want to change the thing, I have to express it as a number. So let's say I do chmod 777 and the target file. So this is the permission I want to apply to the file which I want to edit, not edit, change the permissions. So if I do this and I do this again, you see the permissions change. Everybody able to see? Can you all try that? Create a test file, dummy file, change the permissions. Right? Try adding rwx. Try changing it to rw and x. Oh, can anybody tell me what's the value rwx? Okay, simple math. rwx. Yeah. So let's say you create a file and I want you all to change the permissions of that file to rw and x. So what command would you be inputting?
461.
Yeah.
461.
461 exactly. Yeah, 461. So can you all try that? Create a file, touch, test or something, and then change the permissions of that file to 461. Yeah, you all got it? Yeah? Any questions so far?
So
Yeah.
how do you chmod?
Just type chmod. So the syntax is chmod, the permission, like in this case 461, and the target file. Oops. Does this work for everybody? Can you do an ls la and see if the permissions change? It changed, yeah? Okay, everybody got that? So the reason why these permissions are important is, let's say you you create a file. In this case, I'll give you an example. Let's say I want to read a file. Let's say I want to read the CPU frequency. So my system, you can actually check the CPU frequency. Certain files I won't be able to read the permissions, the contents of it. Let me give you a, yeah, so for example over here, this, if I go inside this, if you can see over here, this file just has write permission, I can't read it. So if I type cat reset, said permission denied. Now unless I type sudo, it will not let me read it because these permissions are held by the root user. Now, funny thing is, even root user can't read it because there are no read permissions. It's only a write. So for us to change that, we need to change the permissions of it. Now I'll not change this because this file is generated by the system. Those files generally please avoid changing permissions. Don't change any permissions of it. It might break the system. Because anything you do with sudo, it does have effects. So you all are very tempted to do that to these PCs, but please do not do that. So that's an example of where permissions are useful. Now, thing is,
we can delete SYS.
I'm sorry.
If you want, we can delete SYS.
So interesting thing is, if you try deleting SYS, moment you reboot the PC, it will populate again, because all of this is stored within the kernel. So kernel, if you remember when I was talking about the boot, kernel decompresses itself and it populates the file system. So if you delete this, when you reboot it, it will show up again. But don't modify contents of the file, because during the working of the system, if you make any changes, it could cause the system to misbehave. So maybe display goes, maybe it freezes, your window manager might not work. These things do happen. Your permissions and there's one more thing called groups. So I talked to you about like what groups are, and groups are essentially an umbrella term where people part of that group can experience all the privileges of that group. So there's a simple command in Linux called groups. If you type groups, it will show you all the groups your user is part of. Can you all try that? Type groups in your terminal. Can anybody read out what they got, what output they got? Yeah. 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 Something similar to what I had, yeah? Okay, you might not have Docker, but that's okay. So, all these groups have their own things, like certain files are related to this, like in plugdev are all your, dial-out are all your TTY devices, your Arduinos, your STMs, any microcontroller you connect, those all come under dial-out, the dial-out group. So, if your user is part of the dial-out group, they can also access that device. That is what groups essentially represent. Now, if let's say you remove the dial-out group from this list, you connect an Arduino, you see, you won't be able to read the data. I wish we had something to try out, but yeah, so you won't be able to read the data. But when you add the user back into the group, you'll be able to read. So to add a user into the group, you need to use a sudo command, sudo user mod -a-g. So what this does is, it modifies the user status. A is essentially append and G is group. So it appends the whatever group I type. Let's say I type input and my user is flow. If I do this, enter the thing. Now it won't show up until I reboot. Some PCs do have that though. And it's not there. But if I reboot it, it won't show up. You can all try that if you want this command. Try adding the input group to your user.
What if we remove group?
Yeah. What if you?
Can we remove groups?
So certain groups, I'm sorry, can you remove groups? Yeah, you can remove groups.
So what if we remove group from group?
You won't be able to execute sudo related things.
Yeah.
So I would recommend you don't do that. Maybe so all these experiments, try it out in a virtual machine. Like virtual machine, it's very safe to play around. You can even do. So you all might be wondering, rmrf, it deletes the directory, right? What if you do rmrf/? More or less like that. So don't do rmrf/. Most computers prevent that. you anyway need sudo to do that. But if you do that, you'll end up with a in a state where you can't even reboot your PC from the command line. No, the reboot command itself won't be there. So don't attempt this in these PCs. Do it in a virtual machine if you want. So yeah, can you all try adding the input group to the sense user? I don't think the group is there in those PCs, but see if there's any other group you can add. The video group. See if you'll definitely have video. I think it's already there. Is it there? Video group already? No, it's not there. Try adding the video group. You able to do that? That means the command executed successfully. Yeah. If you get empty output and you don't get any error, that means it's a successful command.
So can you do the command?
Yeah, sure. Command is this: sudo user mod -a -g, the name of the group and the user. Now, if you reboot your PC, you'll find this group there in your list. And to reboot your PC, it's simple: sudo reboot now. Now makes it reboot immediately. Sudo reboot also does that. You can even set a you can even force it to reboot. Sometimes it doesn't. You can add a F flag to do that. There's one more command I wanted to show you all. So we all were typing ~help, right, for every command. Like any command you take. Sorry? Yeah. So any command, if you want to see what it does, then you do ~help. But most commands in Linux come with something called a manual page, user manual. If you would put it in simple terms. So this documentation is written and then compiled it's compiled to what this kernel reads. So if you type man and then let's say ls, you get like a full description about this thing. And this is like extremely detailed. So it's really huge. Like it's around 223 lines. Try using man. See if you can try any command. All the commands we've seen so far, right? Try using man with them. Press Q, you'll get out of it. You all were able to do that? Any queries so far? I think we can pause for now. I'll take any questions if anybody has any. Till what we discussed so far.
Can you play this last part of
Which one? Man. Yeah, man essentially is a tool, is a command line tool which outputs the manuals for a command. So most commands generally come with something called manual pages. So if a command does have any manual page, it will output that. So let's take a command called rm. To do man rm, it will give you an exhaustive list of it. So help might be just a brief text. Sometimes help and man are same. Generally, developers who are lazy, they do that. They just put that.
What is the use of sudo exactly?
Sudo is super user 2. So if let's say you want super user, the root user to do something, you would add a sudo before that.
Okay.
Yeah.
The root user will execute.
It will execute it on your behalf.
Okay.
That's what sudo does.
What we are using as a root user?
If you're a root user, you don't have to run sudo. Sudo is if you're a root user and you run sudo, it's like hitting a brick wall. Nothing will happen. So for you to switch into root user, you need to do sudo su. Su switches user. Yeah. It switches you into the root user by default. But for that, you need to. Any other queries?